Hi all, and welcome to the Medical AI Lab talk series. I'm delighted that today we have Chenwei Wu talk about Docker and give us a presentation on how to use Docker. Chenwei, take it away.
Hey guys, I'm Chenwei at Medical AI Lab in Harvard Medical School, and today I'm going to give you a quick tutorial on Docker. So by the end of this live tutorial, you'll be able to learn four things. So first, what are the benefits of using Docker for us ML practitioners? And second, how to install and use Docker. And we'll also go over basic commands. And in the end, I will show you how to deploy simple machine learning models using Docker and Flask. So first of all, many of you have experience with virtual machines. So you may wonder, why do we have to use Docker when we already have VM? So both of them are virtualization technologies to allow us to run stuff in a simulated environment. So on the left side, there's a visualization for VMs. So we can see that each virtual machine requires its own OS. The OS and any application running on individual VM share hardware resources under the management of hypervisor, which is also known as virtual machine monitor. So on the right is a container under Docker. So unlike each VM, which needs an OS, library, and binary, and a lot of other things, and they consume more hardware resources such as processor, memory, and disk space, Dockers are really efficient because if you're not running one Docker container, the remaining resources become shared to other containers. And it doesn't require to add an OS in a container either. So we can take a look at one example of a Ubuntu image of a Docker. So if we're using a VM, it must be taking more than 25 megabytes. So this is how powerful Docker is. And so given these advantages, how could we as machine learning practitioners benefit from it? So first of all, I believe we've all experienced scenarios where our teams can run code totally fine on their own machines. But when we take over the code, it takes years to set up and get it running. Imagine we develop a medical AI solution and deploy it to hospitals. It'll be such a pain for both us and the users. So by using Docker, we can avoid going through all that steps again and again, and no more excuses for it worked on my machine though. So it is 100% painless to use containerized applications across different OS platforms. So user like me, I use Windows a lot, never will have any trouble again from booting different systems like Linux. It packages the code and isolates the app from the server, so it literally can run anywhere. It's super reproducible. So next, I'm gonna show you how to install Docker. It's fairly easy. So Docker, as we can see, so we first have to download the image of a certain Docker repo, and then we can run a container on top of it. And then we can utilize volume, which is another feature of Docker, to access and store our files. To install Docker, nothing is special for Mac, but for Windows, you have to actually run Win version check and make sure you're above version 2004, and then go to PowerShell as administrator and run these commands to enable the sub Linux system in Windows. But we're not gonna do that today due to time limits. So next, I will show you some basic commands. So as we just said, to use a public available Docker, we have to first pull the image. So here, let's say we want to build a deep learning model and we want to use PyTorch without all the installation and hectic process. So we can just pull from the official PyTorch repo. So notice how here it says using default tag. So a tag is basically a versioning feature of all Docker images. So by specifying the version, we can just use colon and maybe say like version version like 18 or something. But if we don't specify anything, it's just gonna be the latest as default. So how do we make sure we download the correct images? So if we run Docker images, we can see PyTorch is downloaded and ready to use. So let's head on to run the container on top of the PyTorch image. So let's see. Okay, so we don't see anything running. It's not that we didn't give the correct command. It's that unlike virtual machines, containers are not built to host operating systems. We've discussed this just now. And instead, containers are meant to run specific tasks or processes, like hosting an instance of a web application, database, or for us, machine learning tasks. So when the inside service of the container is stopped, it exits automatically. So that's why we see the PyTorch just ran and nothing feedback is shown on the screen. So how do we check if it's running? We use Docker PS. And yeah, here we see it never run for like more than 1 second. And how do we make sure of that it actually ran? We use Docker PS-A, and we see like exited due to the nature of Docker. So these commands will display all the previous history of running containers. And so here, let's do some basic tasks. So Docker run -it means interactive terminal. And we're first gonna name this because we saw the name here is called Infallible Murdoch, which is a random name. We definitely don't want that. So we're gonna run it as torch1 and specify PyTorch, which is our image, and bash. Okay, so this gives us like a bash terminal that we can run stuff on. Yeah, and if we check Docker PS, it's stopped running because we exited. So is there a way that we can run it like detached in the background? We just simply add D after running. So here we are running it in the, oh, sorry. So this is a common mistake. So whenever you run a container, when you're not keeping the name, just remember either to put RM after run, or you just remove it after. So here we're gonna rename this because the name torch1 is already taken. Yeah, so now we see output something, and if we run Docker PS again, we can see there's a torch2 container running in the background. So how are we gonna get back to our container again if we run it in detached mode? So we can either Docker attach, but that's gonna bring us back to here again. If we exit, it exits. So we're not gonna attach, and instead we're gonna use the exec command. So the exec command, by specifying IT interactive terminal, we can get back to our running process called torch2 here and bash. So we are executing the bash command on top of our running container. So here we can see we got back to our torch container, and OS there's nothing. Okay, so let's assume we want to do some coding here. Python is built in with this PyTorch image. So for example, we want to use pandas, import pandas as PD. Oh, it's not installed. So we're thinking about updating the environment. So we're gonna pip install pandas. And yeah, I know this is basic, but this is to showcase the feature of Docker. And then we exit. So let's suppose next day we want to run another container upon this image. And here we enter again. Let's see if we can find pandas in the pip list.
I don't think you're in the container, Chenwei.
Oh, yeah, please go on.
I don't think you're in the container. That's
Yeah.
all I'm saying. Oh.
Yeah. It's not in a container. Oops, sorry. I just closed my terminal. Yeah, so the reason it is not in a container is due to the structure of Docker. So the structure of Docker is like this. So the image is composed of a set of read-only layers. And whenever you pull the image and run a container on top of it, it creates a read and write layer. So like you're not changing anything inside of the read layers. You're just making file changes in the read and write layers of the container. So that's why whenever we run another container, the read write layer is lost. And that's why we didn't see anything in our new Torch 3 container. Yeah, so how should I update my environments based on my own needs? For example, like how should I keep this change after I pip installed pandas? Let's actually pip install another thing, Jupyter Notebook, because we're gonna use it later. Okay, so one thing you can do is to Docker commit and the container ID. Here's a little trick. So whenever you Docker PS, you see this container name and this container ID. So instead of specifying the whole name of the container, you can actually use the first few characters of the container ID if it doesn't duplicate with any other container. So here, when we're committing Torch 2 to a new image, we're gonna just use 6B because it's unique. And let's make a name as medical AI. Okay, so now it's done. And if I run any container out of this med AI image, it's gonna, let's see, it's gonna give me the Jupyter. So this is RM -- RM means remove this container after running it. So I do this for the sake of presentation. I don't want to create a whole bunch of new containers. So let's make test 1 and IT and med AI bash. So here we pip list. Yeah, we can see pandas here. So it's all saved and stored. So this is how you will change the environment based on your own needs. And so let's get back to the question: how do I save files though? Because that was changing the environment. And here, Docker offers you a lot of ways to share data between containers, share data between your own local file systems, and that's called volume. So there are usually two major ways to exchange data and save data between containers and file systems, and also between containers themselves. So the first one is called a bind mount. So the bind mount uses the host file systems, which is our file system. And the volume on the other way are native to Docker, but it is also kept somewhere. The data is also kept somewhere on the storage attached to our host. So it's often still the local file system. So the volume is have a longer life cycle than the containers. So after we exit the container, after the container is gone, it still persists until no longer needed. So let's try something here. Let's use this command here, docker run, is what we just learned. Name it machine learning 1, IT as interactive terminal. Here is a new command option. So -p is gonna publish to a portal that you can use Jupyter Notebook. And here is important thing. So how do we mount to our local file system? We can use this -v command, and then $ specify a variable pwd. So here I'm using Windows, so it's curly brackets. But I believe for Linux users, it should be just parentheses. And workspace. Workspace is the default path for the PyTorch image, and so is our MetaAI image built upon the PyTorch image. Oops, sorry, I made a mistake. I forgot to enter MetaAI. So let's remove this one and rerun it using our MetaAI. Here, because I forgot to specify MetaAI, it automatically searched for an image called bash. Okay, so this, if we ls, we can see a whole lot of new files, and that's all the files inside my local workspace. That's my local PWD. And we can here use Jupyter Notebook, connect to the portal we just specified, quadruple 8, and IP, just make it 0.0.0. So here we can see that these are all the files inside my own computer local file system. And here's a code folder that we're gonna showcase later about how to save and publish data. Yeah, but that's it for Jupyter. And we can also achieve basically the same thing using by directly creating and accessing a Docker volume, which is the second way I just talked about. So I'm gonna Docker volume create a volume called backup data. Okay, so we can actually use Docker volume ls to see all the volumes we've been using. So here we can see we have our backup data here. Next, we're gonna run name ml2 it, talk about this, so I'm gonna explain again. And here is a new command we're learning, so mount. So we're gonna mount from source equals to get backup data, which is the volume we just created. Specify the destination to workspace, because that's the default medical AI path. And let's see. Yeah. So let's probably make a directory called, oh, it already exists. So I'm gonna make a new one. Test. Okay. Okay, so we can see a couple of folders here. And let's see if we can access the same volume using another container. RM. Yeah, so this is achievable only through volume and volume sharing between containers. If we didn't specify anything, we'll not be able to see the new file changes here. So exit. And you might wonder, like, after I exit or even stop some processes, let's see. So here, torch 2 and torch 3 are running. But what if we want to kind of retrieve history? For example, the ML1 we previously ran. So we can use this command here, *I ML1. So this kind of restarts the ended processes and is easy tool to access previous histories. And so a lot of stuff is covered for backing up the data. But what if I actually messed up and forget to back up the data? Let's see. So let's Docker PS. Let's say I'm already running this torch 2, and if I'm running it without any volume specified, how can I back up the data? So we can do here copy all, and first we're gonna specify the container's name, torch 2, and colon, and the folder inside of it, and the dot in the end is just to copy it to our local drive. Yeah, and the other way is to export all data inside our container by export. So we can also export. This just means out, and out.tar. I already have one, so I'm gonna rename it, and torch 2. It takes a little while. Okay, seems like the files are a little big, so I'm not gonna do that. But yeah, I promise you this command is gonna work if you forget to use any volumes. Yeah, so next, how should I publish my image if I already finished developing and want to share with my teammates? So let's do like a fresh run. Name new ITP workspace meta AI bash. Yeah, should be correct. And let's say we make some changes, like I made a new file like touch avsss.txt. Yeah, and now we're planning to actually save all my changes, save my code, and we're gonna push it to the internet. How are we gonna do that? So here, a new concept is called Docker file. So Docker file uses like a different syntax and Docker commands, and it's how you're gonna structurally and efficiently build your current container into an image, and it's easier to push to the public. So here we're gonna WSL nano. For Linux users, it's just nano.txt. Okay, so let's go through this Docker file.txt line by line. So what is it doing? So from specifies the container that you're gonna build an image from. So we made a fresh run called new here. So next we're gonna build from it. And run includes the running commands you're gonna you wish to make it run along with building the image, like making a directory src, change the container's working directory to src. And since we have connected with our local drive, we want to copy the code folder and everything inside of it to our container. So the first one is the local you want to copy from, and second one is a container path. And here dot means just src, which we just changed. And also there's a requirements.txt inside my code folder. And apart from that, I also want to install Jupyter. So this is an example of a Docker file. So sorry, I'm gonna save it, and next we're gonna build it. Build T. So I'm writing in this way because my username on docker.io is Chenwei W, and there's a repository called medical AI underneath it. We can also specify the version using the tag syntax, which is just basically colon and version, let's say 99, and we use F to access Docker file we just built. Oops. What did I miss? Docker file. Oh yeah. Yeah, so now it's built successfully. And we have to make sure we are logged in, and otherwise it won't push. Then we can just push Chenwei W meta AI version 99. Great. So if we go to the public website of docker.io, it's going to be there. Let's see. So this is my meta AI repo. Yeah, we can see just a few seconds ago, I pushed version 99 of medical AI. Okay, so that's a lot of basic commands. And so next, what if we wrote a chest X-ray classification model and we want to deploy it as a containerized web app? So here, I want to do git clone. Let me just copy it. It'll be faster. Oh, sorry, I already have it. Forgot. So let's cd to it, and so what I want to show you is how to build a web app with Flask after building a model, and also how to Dockerize it using the knowledge we've just covered in the previous tutorial. So let's look at our code. So first, building a model. Here, for the sake of presentation, I didn't write any fancy deep learning models. My predict class function just returns a string, whatever you give them. And so how to build a web app with Flask. So you basically create a Flask instance, and then you specify the sub web page after your main web page, specify your methods. And so here we're planning to build a website that doctors can upload a chest X-ray image and then read our classification result. So we're going to utilize the upload set from Flask. So we make a function here called upload. If the requested method is post and we detect there's actually a photo in the files that request just received, we're gonna in reality pass through this predict class function. But since this is just a vanilla model, we're not gonna pass it. And then we answer and return it. And if not getting a uploaded file, we're just gonna render the default HTML file. And yeah, so next step is to Dockerize it. So here we're gonna make something different than we previously did. So let's look at our Docker file. So in reality, not a lot of users are willing to download like 6-7 gigabytes image. So here we're just gonna use the base image from Python. Is like decently small, and same as before, we're creating a work directory and changing it to the containers default, and copy all files inside of my GitHub repo. And we're gonna run the requirements. And also here, so if you're using a web app, you're probably gonna want to expose to some portal. So here we specify expose to 5,000, and we set the entry point. So the entry point is the program you're gonna run when the user actually starts running your Docker. And CMD basically just stands for command. So we're gonna run our Python upload.py. So that's what I'm writing here. Yeah, you can definitely change it to Python predict model and other stuff with more built models, not just this one. Yeah, so next, we already have our new Docker file. We're gonna build it like we just did before. So we're gonna build f Docker file and tag it as image classifier. Okay, so it's successfully built, and then we're gonna run it and see if it works. So when using it, because we just now exposed our web app to 5,000, so we're gonna stick with that. So run and yes. Okay, so check it is running, and here we could see that if we go to our localhost upload, we can choose a file. For example, this is my machine learning homework 1 image. We submit it, and it returns our expected output. Yeah, so after all that, we've successfully built a Dockerized Flask app, and then we can just share it and give it to your team or the public. Yep, that's basically my tutorial. Thanks all.
Thanks for the
Open for
fantastic
questions.
Thanks for the fantastic presentation, Chenwei.